Assalamualaikum and hi, we are from group Extraordinary. We present a video of how to name a coordination compound, and this is a group members.
The coordination compounds are named in the following rules. Rule number 1. The ligands are always written before the central metal ion. Rule 2. Determine the charge of the ligands, whether it is negative, positive, or neutral. Next, Rule 3. If the coordination center bound to more than one ligand, the names of the ligands are written in an alphabetical order. And rule number 4. Greek prefixes are used to indicate the number of each type of ligand when one or more than one is present in the complex. Rule 5. After the ligands are named, the name of central metal atom is written. And the last rule is Rule 6. To determine the oxidation state of metal and calculate the total charge of the ligands. Now, let's go details on how to name the compound according each rules. The first rule is the cation is named before the anion. Let's see on this example, K3FeCN6. The first part represents cation and the second part is anion, which carries the negative charge. Next, rules number 2. Determine the charge of the ligands, whether it is negative, positive, or neutral. The names of anionic ligand should end with the suffix O. The first one, ide suffix change to O. For example, bromide change to bromo. For ide suffix, it changed to ito. For example, sulfide changed to sulfito. And the last one, ate suffix changed to ato. For example, carbonate changed to carbonato. Meanwhile, neutral and positive ligand referred by the usual name. Exceptions for carbon monoxide will be changed as carbonyl, ammonia will be amine, nitric oxide will be nitrosyl, and water will be aqua. Third rule. If the coordination center bound to more than one ligand, we should name the ligand in alphabetical order. In case your complex have ligand 1, which is carbonate, and ligand 2 as amine, so the amine is written before carbonate.
Rules number 4. When there are many monodentate ligands present in the coordination compound, the prefixes that give insight into the number of ligands are di, tri, tetra, penta, and hexa. Meanwhile, when there are many bidentate ligands attached to the central metal ion, the prefixes are of the form bis, tris, tetrakis, pentakis, and hexakis. If the complex is an anion, the central atom's name will end in ate, except for mercury. For example, if the transition metal is candium, the name in cationic complex is candium. Meanwhile, the name in anionic complex is candate.
Rules number 6. There, we need to find the oxidation state of the metal atom. So, for example, determine the oxidation state of cobalt atom. As we know, the potassium is going to be positive 1, and anionic complex will become negative 3. In this complex, we know that ligand fluoride charge is negative 1. Meanwhile, X will be a cobalt. To calculate charge of cobalt, X plus 6 that multiple with negative 1 is equal to negative 3. Then X minus 6 is equal to negative 3. And then the answer we get is X equal to positive 3. So, X, which is cobalt, is in positive 3 oxidation state. Now, let's practice. Write the IUPAC name for this complex. First, let's identify the cationic and anionic part in this compound. As you guys can see, here the counter ion is chloride, which is an anionic. It means the compound in the bracket is cationic part, which means it positively charged. Now, let's identify the charge of the ligand according rule number 2. In this compound, they have two ligands which are amine and water. These two ligands are neutral, so we no need to change the suffix of the ligand. Based on rule number 3, as there are two ligands present in the compound, name them according to alphabetical order. The first ligand will be amine, and next is water, which its name become aqua. After that, there are 4 amine, so it's become tetraamine. And there are 2 water, so it becomes diaqua. Thus, it's become tetraamine diaqua. This is stated from rule number 4. Now we are halfway completed naming our compound. Let's look at our metal. You guys can see we have cobalt, the transition metal. So, the name in cationic complex will be as its usual name, which is cobalt. Lastly, how do we know what oxidation state in this cobalt ion? Whether it is positive 2 or positive 3? Thus, based on the last rule, we need to determine the oxidation state of the metal. So, we put cobalt as our X. Since the chloride is -1 times with 3 becoming -3, the overall charge in the bracket will become positive 3, since the total charge of the compound must balance to 0. Meanwhile, in the bracket, water and amine are neutral, meaning the charge are 0. The calculation will be X plus 4 multiple with 0 plus 2 multiple with 0 is equal to positive 3. And the answer we get for X is positive 3. So, cobalt is in positive 3 oxidation state. Finally, we can put our counter ion, which is chloride, as the last part of naming our complex compound. In a nutshell, the name of the compound is tetraamine diaqua cobalt 3 chloride. Easy, right? I hope you guys can try it on for another coordination compound. Good luck!